There are three fundamental laws of motion, discovered by the English mathematician and scientist Sir Isaac Newton, all the way back in the 17th century. In this video, we will describe and apply Newton's third law of motion. The third law of motion states that for every action, there is an equal and opposite reaction. For example, the swimmer pushes against the pool wall with her feet and accelerates in the direction opposite to that of her push. The wall has exerted an equal and opposite force back on the swimmer. The forces are equal in magnitude or size, but opposite in direction. Forces always come in pairs, the action and reaction, and often is not clear where the second force is. Think about someone sitting on a chair. Most will spot the downward force of weight, but will not consider the force of the chair on the person. It's easier to see this reaction force if she sits on a trampoline instead. However, there are actually two pairs of forces acting here. The man's weight is balanced by the gravitational force he exerts on the Earth. He is prevented from falling towards the Earth's center because of the upward force from the trampoline or chair, which is balanced by the force he exerts on the chair. The forces are equal in magnitude or size, but opposite in direction. Or pushing a book at constant speed across a table. The force pushing the book acts towards the right. The force of friction opposes this and acts towards the left. The arrow vectors are equal in length because the magnitude of these forces are equal. There is another pair of horizontal forces acting here. The book is trying to drag the table as it is moved to the right, but the table is kept in place due to the opposing frictional force where the table legs touch the floor. We mustn't forget the pair of vertical forces acting here as well. The weight of the book on the table and the upward reaction force of the table on the book. Consider a rocket engine in outer space. Hot gases are expelled from the back. The rocket pushes against the hot gases, and the gases exert a force on the rocket, which causes it to accelerate. At liftoff, there is another pair of forces between the rocket and the Earth, as we saw before with the chair and the book. So there are now two forces on the rocket. If, as we hope, the force from the exhaust gases is greater than the force from the Earth, its weight, we will get liftoff. Many people are familiar with the fact that a rifle recoils when fired. This recoil is the result of the action-reaction force pairs. A gunpowder explosion creates hot gases that expand outward, allowing the rifle to push forward on the bullet. Consistent with Newton's third law of motion, the bullet pushes backwards upon the rifle. The acceleration of the recoiling rifle is A, greater than the acceleration of the bullet, B, smaller than the acceleration of the bullet, or C, the same size as the acceleration of the bullet. Pause the video while you work it out. The answer is B. The force on the rifle equals the force on the bullet. Yet, acceleration depends on both force and mass. The bullet has a greater acceleration due to the fact it has a smaller mass. Remember, acceleration and mass are inversely proportional. For more on acceleration, watch this video. And that's how Newton's third law can be applied.
If you liked the video, give it a thumbs up and don't forget to subscribe. Comment below if you have any questions. Why not check out our FuseSchool app as well? Until next time.